All right, so in this section, we're just going to be doing some word problems involving quadratic functions and, graphing, max, min, all that nice stuff. You can go ahead and pause and write this down if you need to. I'm going to read it once and then start going with an example. A rock is thrown on the fictional planet Calculon, and its height in feet corresponds to the equation h of t is equal to negative 2t squared plus 12t plus 32, where t is the number of seconds that have passed since the rock was thrown. So we have a few things here. This h of t represents the height in feet, and t is the number of seconds that have passed since the rock was thrown. Okay, so number of seconds there is probably the most important part. Okay, so let's ask a question then. Let's say part A, after how many seconds does the rock reach its highest point? This is very similar to the problems we were working on in the previous section. I'm really just asking for the local max here. I'm telling you the rock's being thrown upward, and I want you to figure out when do we get to that highest point on the trajectory of this rock. So I'm going to do the exact same way I did the previous problems. I'm going to rewrite my function. H of t is equal to negative 2t squared plus 12t plus 32. Going to get a setup for completing the square here. Factor out a negative 2 will leave me with a t squared minus 6t. I'll leave the 32 on the outside. I have a negative 6 in the middle there. Divide by 2, square it. That gives me negative 3 squared. I'll put that in green to remind myself like I was on the previous section. But negative 3 squared is 9. So I need to add 9 to the inside here. When I do that, I have a negative 2 on the outside. Negative 2 times 9 is negative 18. So to balance that, I need to add 18. And okay, so now I've completed the square. I can go ahead and factor this. And looking over there, my green underline, this is going to be t minus 3. And on the outside, we have a 50. So let's see here. Part A asked, after how many seconds does the rock reach its highest point? And, well, how many seconds? That corresponded to t there. And so that is going to be t equals 3. If you were to graph this, and you don't have to, but if you were to graph this, you would be going to the right 3. So t is going to be 3 seconds here. And I'll tack on a part B as well. Let's say for part B, how high does the rock go? Again, if you wanted to graph it, you can. You know how to do that. Okay? But you don't really have to. We already know from our completing the square above, we already know there that, let's do it in green. I've already used green. Let's do red. We already know it's going up 50 there. And so we're going up 50 on the h-axis or the y-axis or whatever you want to call it. So h there is going to be 50 feet.